Okay, so this is another example like the last one we did, all right? So we're going to have to isolate the radical twice, is what we're going to have to do. So square both sides. This will be 8 minus x. And here we're going to have the same thing written twice. 2 plus root 2x plus 3 times another one. 2 plus root 2x plus 3. All right. So we have 8 minus x. 2 times 2 just gives us 4. Now, here, everything's positive, so it's kind of easy to keep track of. We have 2 times that. And then next we're going to have 2 times that. So we're going to have 4 of them all together. So that'll be 4 root 2x plus 3. So I'm doing this multiplication and this multiplication, but I'm just adding them up as I go. All right. And then we have 2x plus 3 times itself. So that's just going to be, root 2x plus 3 times itself. So that just gives us 2x plus 3. All right. Let's see again, the 4 and the 3, we can just call that a 7. All right. So plus 7. And let's subtract 7 from both sides and subtract 2x from both sides. All right. So we'll wind up with 1 minus 3x equals 4 root 2x plus 3. All right, in that last example, we were able to divide everything by 4, but we can't with this one. So let's go ahead and square both sides. We've got this radical isolated, so that's why we want to do that. All right, let's multiply 1 minus 3x times another 1 minus 3x. That'll be 1 minus 6x plus negative 3x times negative 3x will be 9x squared. All right, then we wind up, not with a 4. 4 squared will be 16. Then we'll have a 2x plus 3 inside. All right, expand this. That'll give us 32x. 16 times 3 is 48. All right. Subtract 32x from both sides. Subtract 48 from both sides. All right, so this side's gone. It gives us a big 0. Let's write this in standard form. We've got a 9x squared. This is going to give us a negative 48x. And this will give us a negative 47. All right, so I can't divide by anything. I am not about to do 9 times 47 and look at those factors. Although 47 is prime, but I think I'm just going to go with the quadratic formula here. All right, so we have negative b, which is 48. Negative b plus or minus square root of 48 squared. It's negative 48 squared, but it turns out positive. Minus 4 times a times c all over 2 times a, which is 18. Wow, this is going to be large. All right, let's just focus in on this square root here. 48 squared minus 4 times 9 times 47. And we get 612. Okay. 612. 48 plus or minus 612 over 18. Oh, sorry. There we go. Over 18. Now, we could try to simplify this 612, the radicals, but before I do that, I'm going to go ahead and see if this will work for my original equation. All right, so I'm going to be using the store function. So let's see what I've got here. Are you in view? Yes. All right, so make my alpha y equal. All right, and I have my numerator. I'm just going to do the plus version this time. So 48 plus the square root of 612 over 18. I know I haven't simplified it, but I'm going to see if it works. If it works, then I'll go through the work of simplifying it. And I'm going to store that to x. All right, enter. All right. So my calculator believes that x is equal to all that stuff. So let's try plugging this in for the original. All right. On the left side, we have square root of 8 minus x. All right, that gives us 1.98. Let's remember that here. The left side is 1.98. On the right side, we've got 2 plus the square root of 2x plus 3. I don't have to put parentheses here, do I? All right. And we get 5.32. So we got something else, right? So that means that the plus version does not work. All right, so let me kill that one. It's extraneous. It actually means that the negative one won't work either, but I'll go ahead and punch the button so you see. All right, let me go back up to where I type that in, and we'll just make that a minus sign. All right, so now the x thinks that it is the negative version. All right, let's see what the left side gives us. Square root of 8 minus x is 2.5. Let's see what the other side gives us. 4.36. So we did not get the same thing back from the left side and the right side. So that means that both of our solutions down here, the plus and the minus version, were extraneous. They were no good.